Hey everybody, we're looking at the bottle line simulation, exercise number 1. This exercise, there's not a lot that you really have to figure out. It's just there's a good bit of reading to it. If you go up here, there's like some background information about Boolean states, Boolean being a 0 or a 1, or a true or false, depending on what kind of system you're looking at. And we're going to shift this Boolean data to the left in this case. You can shift it left or right inside a byte or bit or word. Well, not inside a bit, but you'll see what I mean here in a second. So essentially all you're doing is making a stop-start circuit and copying what they already have drawn out here in the instructions. So it says create a program which allows the operator to start and stop the process using the available panel-mounted switches. When the process is running, the main conveyor should be energized and the bottle should continuously enter and exit the line. So that is this stop and start here, and I use this run light, and this is the motor, the main motor conveyor output 2/0. So when you energize the output 2/0, or wait, is that 20 or 210? Yeah, it is 20. Sorry, I was looking at my wrong output there. 20. 210 is going to be your run light right here. So if you mouse over them for a second, it'll pop up and tell you what your output is, or you can just drag it over onto your logic. Also, it tells you for these exercises, please utilize the bits in word B30 if and when single bits such as flags are required. What they are talking about is, if I exit there, here's your binary table. So B30 is this top column or top row here. So bit 0 through 15 in the row B30. So these are all binary digits or bits, meaning they're going to be a 0 or a 1. And it says use the word B30. So 8 bits is a byte. An individual location is called a bit. I'm trying to remember what a nibble is. If 4 bits is a nibble, but there's a term for a smaller group of bits. And then you can have a 16-bit word. This is a 16-bit word. So you might look and say it only goes to 15, but they're counting 0. That's why it's 16-bit. You can also have a 32-bit word, depending on what kind of system you're using. So the interesting thing here, one of the interesting things is that we specify the length on these bit shifts as 32, but then we specify the file as B32. So let me go down here. B32 is right here. So there's only 16 bits in B32, but we specify the length down here as 32. So what's going to happen, I'm jumping ahead a little bit, but what's going to happen is it's going to shift all these bits over, and then it's going to start on B330 and fill them in from right to left in this case. You can see it filled them all in with 1s, and there's only 5 left that haven't got overtaken by the steady procession of 1s that come out of the input 1/6. So what we're looking at here is this sensor over here is, if I mouse over it, it should tell me what it is. It's not going to tell me, but yeah, there it goes. Input 1/6. That's this input here, and it's also this input here. That's just a limit switch telling you that there's a bottle there. So every time a new bottle comes out, this is going to go from false to true, or low to high. When that happens, or I should say in the input table, there's lots of ways to think of it. In our input table, input 1/6 is going to be right here. So you see it's a 1 right now. Whenever this location goes 1, meaning that sensor detected a bottle there, or true, this will close, technically isn't the right word, but it'll be true. Like here you see it's highlighted in yellow, meaning currently it's true, and you see in the bit table it's a 1 right there at that location. So when that happens, it's going to energize all 3 of these bit shifts. And you can see that they're energized and they're done bits also made. So we'll break these down one by one. When these are energized, binary here, this is, see, this is the most confusing one to try to explain it on, is the top one, because they're all 1s, so you can't really see any difference. So we'll go to the middle one, which is the large bottle detector. That is this one that's purple here, the one that's not currently not true. And that is B34 right here. Let me just try to put that up there. So this is the memory location that all the data from input 1/7, or the large bottle detector, that LS2 right there, every time that senses a bottle, it's going to take that data and say, is it a 0 or a 1? And then it's going to load it into B34 bit 0. So the word, the 16-bit word, is B34, and the bit in that word that we're putting our new data in is bit 0. So every time this triggers, it's going to look at that input and say, is this input true or false? Is it a 0 or a 1? So that's why you have your bit address right here. And it's going to take that data and put it in the file B34. You can also right click here and go to data table, and it'll pop up. Here's B34. So it's going to say right now it's a 0 at this location. I'm going to put it in B34 bit 0 right here. Then when it gets the next one, well, also when it gets that one, but when it gets the next one, when this triggers again, a new bottle will come on the line. It'll trigger this LS1 switch right here. After this one shifts, this bottle goes to the right, next bottle will come in. It'll trigger this. The bit shift will detect again, but it'll be detecting the next bottle over. In this case, it'll also be false again because it'll be detecting this bottle because everything will have moved over to the right one. When it detects that bottle, it's going to again look at input 1/7. It's going to say that it's false. It's going to put a 0 in this location, but it's not going to overwrite the existing 0. It's going to shift everything over to the left 1. So it's going to take the 0 that's here, and it's going to move it over to bit 1 in word B34. So you'll have 2 zeros here. And then if we look here, there's a bunch of short bottles. So it's going to start loading up with zeros. Every time a new bottle comes out, it's going to trigger this, and it's going to look at that sensor and see if that sensor is made or not, and it's going to put that in bit 0, and it's going to keep pushing the previous ones to the left, to the left, to the left. Little Beyonce reference for you there. And when it gets to 15, it's going to wrap around to 0. So even though it only specifies B34, it says the length is 32 bits, and there's only 16 bits in that location. So after it gets to 15, it'll pop down here and then keep pushing over to the left until it runs out of locations. That's why in their example, they specified B32, B34, and B36 instead of 32, 33, and 34, because if they did that, they'd only have 16 bits of space, and then the next one down would be where you're storing the data from the next sensor, and you'd only be able to have a length of 16 bits. Another pro tip here is a lot of the times when you reset the simulation and you clear the data out, it'll reset these lengths to 0. So if you go in here and you look at your data table and you see that nothing's changing, it's not updating these, and it was before, your lengths probably got reset to 0. You didn't type them in there, but there's one of the resets that you can do on the simulation part that'll zero these all out automatically, and then you download it and run it and you don't understand why these aren't working anymore. It's those got reset automatically by the program back to 0. So the length that you're storing the data in is 0 bits long. So let me run this so you can see what it looks like here. Download, and we'll go to run, and we'll go to start. And we'll go to the data table. So this exists one, which is input 1/6, which starts at B32 right here, bit 0. It's going to be a 1 every time because every time a bottle comes on, it's triggering. It's sensing every single bottle, so it's always going to be true. It's just seeing, is there a bottle there? Unless a gap came on this line, which I haven't seen happen yet. If there was a space where there wasn't a bottle, that would not be triggered and it would have a 0. But that would never happen because it only actually fires these bit shifts when so it's recording that, but it's also fired by that. So these bit shifts don't activate until that triggers. So you're always going to have 1s there. So it fills up the whole way over, and then it starts wrapping around and fills in the second column, or second row there, sorry. So let me pause this here. And the next one down here is B34, and that is detecting large. So it has a 0 there, and that would be this bottle. It's this middle sensor. And you see right now it's at a 0 because it's not being made because there's a short bottle there. And if you follow it back, there's 2 large, a short one, another large. So if you go this way, 2 large, a short one, another large, and 3 short ones in a row. That's these 3 short ones. Then 1 large and 2 short ones, 1 large, 2 short ones. So you can see every one of these 1s is the time that this sensor detected a large bottle. And if we play it, you'll see that these are all just slowly jumping over to the left. Once they get here, they'll wrap around. So let me make it a little easier to concentrate on what we're actually looking at. So it starts on bit 0 here. So these group of 3 ones, you can see we can just follow it all the way across. And when it gets here, they start filtering in down here, and they're rolling across from right to left on the next 16-bit word right underneath it, because we set our length as 32 bits. And every time it senses a shorter or tall one, it makes it a 1 or a 0, it drops it in there, and then when it triggers again, it says shift what was ever in 0 over to the next one, shift what was ever in 1 over to 2. Basically shift everything over to the left one time, and when you get to 15, roll it over to the bottom side. And the exact same thing with the broken ones. So we can go down to 6 and 7. There's a lot less broken ones. So there's 1, and then there's 3 good ones in between it. So there's that 1, and there's the 3 zeros in between it, and another 1. Because each time it detects a broken, that sensor goes true and writes a 1 into that location. So it looks like we're getting a lot with 3 good ones. There's 2 broken ones in a row. There's the 2 broken ones in a row for that right there. Now we're getting a lot of broken ones, so we'll see a lot more 1s coming up here, shifting across. And that's it. So the important part to know, I mean, you're really not having to figure anything out other than write your stop-start circuit, which is we've done a lot of already, is just to understand how these work and what they're actually doing. Because the next thing you're going to have to do is drop the large bottles down through here. So you have to figure out, the large bottles are B34, and B35. So you have to figure out where, once it detects a large bottle, where that 1 is going to be in these binary addresses when it is over top of this solenoid. So this one is a large one, so there will be a 1 over top. So you have to kind of figure it out. It's going to be 4 zeros. Let's see a location with 4 zeros on here. Oh, because it's in the wraparound area. So here's the 4 zeros. And then 2 larges, that's these 2 larges, then a short one, and then a big one. So it looks like it's going to be this one. It looks like it's going to be 355. So that bit is relating to this bottle right here. So I can say when this bit is a 1, I'm not sure, I'm not going to do that till the next video because that's the next exercise, but you would trigger this solenoid to open up based on whether this bit location is true or not. So you'd have a, I know Alan Bradley doesn't like to use normally open, but you'd have a normally open contact like this run light associated with this B355, and whenever that's a 1, it would trigger and actuate the output for this solenoid and open that door, so it would drop out anytime that large bottle that was detected earlier is in that location. So I'm going to move on to my next video for exercise 2, and we'll get more in depth on that.